All right, on number 2, you notice that the common difference between each pair of consecutive numbers is 7. So D is 7. And here's the formula that you wrote down in your notebook today. The only thing with this one is that this one starts with a 0. So this formula will not work as it's written. So we have to make a little adjustment and use this one. Starting with a sub 0 plus d times n, and then this would, we'll say n is greater than or equal to 0. Okay, and the reason we do that is because if we use the first one, we would put in a 0 right here, and then we'd get a -1, and that wouldn't, it work out, but it wouldn't give us the same list that we have right here. Okay, so we're going to use this one. So f of n, a sub 0 is -6, the difference is 7. So then f of n is -6 plus 7n. And you can leave it like this is fine. For the recursive, we start with f of 0, that's our first number, and then f of n equals the previous number, or previous term, plus 7 for n. Now n goes from 1 to 4, right? We have the first number right here, this number right here, but then we still have to account for these 4 right there, right? So n is between 1 and 4. So here's the recursive, and here's the explicit. Alright, so number 3 is another arithmetic sequence because the common difference is -3. This one also starts with the n equals 0, so that's why we're going to use the purple formula that's on the screen right now, okay, instead of the one that's in your notebook. So we have f of n is the a sub 0, which is 8. The difference is 3. And so we write f of n. There's really nothing to simplify here. And so n is between 0 and 4, including 0 and 4. Okay, so the recursive formula, so this would be the explicit. The recursive formula, we start with f of 0 equals 8, and then f of n is the previous term minus 3, and in this case, because f of 0, n equals 0 is already accounted for right here, the ones that are left are n between greater than or equal to 1 and less than or equal to 4. So here's the recursive. Okay, so for number 4, they gave you the recursive, and they're asking you they're asking that you write the explicit. So you would say f of n equals the first number on the list, which is 6. The difference is 5. Okay, and since we're starting with 0, we just do the n. Okay, and then we just say n is greater than or equal to 0. Number 5, this one does start with n equals 1. So it's going to be f of n equals the first number on the list. The difference is -10 times n minus 1 for n greater than or equal to 1. And then we just simplify, so it's 19 minus 10n plus 10. Combine the 19 and the 10, so f of n is 29 minus 10n, and greater than or equal to 1. Alright, so for number 6, we're going, they're giving you the explicit and you're writing the recursive. So based on the way this is written, we see that this is the initial number, the a sub 1, because if you put a 1 in here, you get 0. And then so that means that all this is canceled out. So that's my initial number. Alright, so I'm going to write f of 1, f of 1 equals 9.6, and then f of n is the previous term minus the difference. The difference is negative 0.2, and n is greater than or equal to. Since n equals 1 is already on the first line, here we put 2. So these two combined make the recursive formula. Alright, so for number 7, we have n is greater than or equal to 0, so when you put a 0 here, that cancels out this term, so your initial number, your first number is 14. Okay, so we're going to put f of 0 is 14, and then for the rest of it, it's the previous number. The difference is 8, so it's positive 8, and then n is greater than or equal to 1. Because f of 0 is already in the first line, so the next one up is 1. That's why we put the 1 right here. Alright, so for number 8, it doesn't tell you where to end. It just says that n is greater than 0 or equal to 0, so we'll just write the first few. So we replace the n with a 0, and you get 7. So the first number is 7. And then the difference is negative 1/2. So we keep subtracting 1/2 from the previous number. So this would be 6.5, 6, 5.5, 5, and we ... So now we're going to graph it. So we start off when n is 0, f of n is 7. So this one's right on the axis right here. And then this is n is 0, 1, 2, 3, 4. Okay? So when n is 1, we get 6.5. When n is 2, we get 6. When n is 3, we get 5.5. And when n is 4, we get 5. Okay? And we could keep going. My list didn't go that far, but we could keep going. So it's just down 1/2. I could stop right there. Alright, for number 9, they're asking you to go from n equals 1 to n equals 5. So when n is 1, f of n is 3. So this would be 3. And we're adding 2 each time. So 5, 7, 9, and 11. Okay, so there's 1, 2, 3, 4, 5 numbers. And that's what we're going to graph. Alright, so here's the setup. So when n is 1, we get 3. When n is 2, we get 5. When n is 3, we get 7. When n is 4, we get 9. And when n is 5, we get 11. Okay? So remember, these are discrete graphs. We do not connect the dots. Alright, for number 10, we're starting with n is 1. So, oops, I forgot to copy the whole thing. Sorry. F of 1 is negative 0.5. So my first number is negative 0.5. And then it's going down by 1/2, by 0.5. So negative 1, negative 1.5, negative 2, ... Okay? And so now we're going to graph. So when n is 1, we get negative 1/2. Notice on the vertical axis, I counted by 1/2 every square. When n is 2, you get negative 1. When n is 3, you get negative 1.5. When n is 4, you get negative 2. And you could keep going on and on, but I'll just stop right there. I guess you can do a couple more, but have a little bit of room. So that's fine. Alright, so for number 11, it starts with negative 5. And we're adding 3. So then we have negative 2, 1, 4. Now it starts with n is 4 to, n is 0 to n is 4. So this is n is 0 right here. 1, 2, 3. We need one more number. Okay, so 4 plus 3 is 7. So that's the list that I'm gonna graph. So when n is 0, you get -5. When n is 1, you get -2. When n is 2, you get 1. When n is 3, you get 4. And when n is 4, you get 7. Finished? Nathan! You didn't close the door.
Oh yeah.
Okay, so for A, the difference between the first two is 0 and then the next two is 1. So right off the bat, we know that it's no. It's not arithmetic. Okay? It is a special a sequence called the Fibonacci numbers, because if you add the first two numbers, you get the next one. You add those two, you get 3. You add these two, you get 5. You add these two, you get 8. You add these two, you get 13, and then 21, and then 34, and so on and so on. But it's not arithmetic, okay? Letter B, you have difference here, 3, 3, 3, 3, 3, 3. This one is yes, the difference is 3. This one, these are square numbers. The difference is not the same. That's 1 and that's 2. So it's not arithmetic. They are this list of square numbers though. The next one, you add 7, add 7, add 7, 7, 7. This one is yes. The difference is 7. Letter E is not arithmetic. There is a pattern. All the numerators are consecutive. 1, 2, 3, 4, 5, 6, 7, 8. The denominators are also starting with 2, 2, 3, 4, 5, 6, 7, 8. But the fractions themselves are not, there's no common difference. So this one's no, not arithmetic. Letter F, this one would be a negative 5 between here, negative 5.5. This one negative 5.5. The same, and the same. So this one is yes. The difference is negative 5.5.